All right, y'all. Today we're going to learn about a thing called object inheritance, which makes objects even more handy while also saving us some time and effort and organizing our code in a more intuitive way. So you will notice that right now what I have up is not a compiler or an IDE. This is just a diagramming tool. This one in particular is created by Draw.io, which is nice because it saves into your Gmail or your Google Drive account. But there's a bunch of tools for this. It doesn't matter which one you use. The only thing that is important is that most people use what's called UML, which is Unified Modeling Language, which is really just a kind of a standardized diagramming tool. So let me show you how that works just a little bit. So the first thing I'm going to do is I created a UML diagram from draw.io. I got it saving in my Gmail account. You guys are good with all that stuff. It's pretty chill. You don't have to use this tool. You can use a different one if you want. I created a UML diagram and then I deleted all the templates so you could see me start from scratch. On the left-hand side here, I went all the way down to the bottom and there's this UML choice. So I grabbed that. And then I'm looking in here and I'm talking about classes right now. So this is called a UML class diagram that I'm playing with. So I'm just going to grab this class box and I'm going to just center this one up on the screen. It doesn't really, it doesn't really matter much. Okay, so the example I'm going to use right now is I'm going to do a little diagram for my kind of pets that I have. So it's extremely common to have to do this for video game design, to have to do this for web app design, for phone app design. All those kind of things are usually built in an object-oriented way. And when we start having lots of objects, it starts being hard to keep track of what's what. So for my example, I have pets, right? And so I have this kind of abstract idea of pets, and then I have different types of pet. So I have a cat and 2 dogs. So I'm going to make a pet class that's going to cover kind of the generic idea of a pet. And then I'm going to have subclasses. I'm going to have a cat subclass and a dog subclass. And I'll show you how to do that in UML, and then we'll show you how to do it in code. So this first thing is going to be what's called the parent class or the super class. So that's going to be the pet. And then there's these field and type things. And for right now, I'm just going to use plus signs. There's some meaning to what that symbol is right there, but we'll get to it later as we do more advanced things. So I think pets have a name, and that's a string. And I think pets have a weight, and that's a float, maybe? Oops. Not a flout, but a float. And I think pets also have a color. And that's also going to be a string. Okay, and then you'll note I have some kind of spacing type issues here, so I'm just going to make this a little bit bigger and then make it the right size. Okay, so I have names that are strings, weights that are floats, colors that are strings. These are just the important things that I think of when I'm keeping track of pets. There might be more things or less things or different things, and that's all fine. The only thing is that those are strictly variables. What I mean by that is they shouldn't themselves be objects. There's a different way to do that. We'll get to it, I promise. So pets have names, weights, colors, and pets have methods. And the methods are going to be, let's see. So in my generic pet class, I'm going to have an init method, right? Which is going to take nothing and return nothing. And then I'm going to have a say hi method, which is just kind of a generic say hi method. And that's going to be mostly for debugging for me because I'm not intending to make an actual pet. I'm intending to make a dog and a cat, or 2 dogs and a cat in my implementation. But I'll get a little bit more into that in a minute. Okay, so there's my pet class. Now I intend to have another class based off of the pet class. So that's kind of this one. And that's going to be, I'm going to start with cat. Okay, and then I need a way to make it clear that cats are a kind of pet. And so what I'm going to do is over here in the arrows, if you kind of hover over these, it'll tell you what they are. I'm going to find the one that says generalization extends. And then I'm going to drag one end of that arrow onto the top of my cat class, and I'm going to drag the other end, and I'm just going to point it at this bottom box. And the arrows in here get a little finicky. So the first thing I'm going to do is I don't need to know that that arrow means extends, because that arrow does mean extend in UML. So the hollow arrow is an extension arrow. And then I'm just going to pretty this thing up just a tiny little bit, because frankly, I think it's kind of dorky looking the way it is. Okay, so I got my prettied up cat is a kind of pet diagram here. And cats are going to have a couple different fields. So cats are going to have an inside field that's a Boolean, or an inside property that's a Boolean. And that's not how you spell the word Boolean. And then cats are also going to have a declawed property. I just couldn't think of anything else that applies to cats. Probably shouldn't declaw your cat, but you also shouldn't let them go outside either, so whatever. Shouldn't let them go outside because they wreak havoc on little lizards and stuff. Okay, what else? Oops. That was the wrong, this one. Okay. So there's my two additional fields that a cat has. They also have these fields because they are a pet. I hope that makes sense. Right? Because a cat is a type of a pet, it already has this stuff, and so I don't need to reiterate that. Then for methods, cats are only going to get a say hi method. Right? Oh, and I guess maybe I'll give the dogs a special method. Oops. Okay, and then I need another one of these, and you can either just duplicate this one if you want. That'll work. Just put it over here someplace. You might just duplicate this arrow. That arrow needs to be pointed at the bottom box and over here, and then we have to kind of scooch some arrows around. Okay, and I have a clear issue. There we go. Okay, so there's my arrows done, and then this is going to be a dog, right? Is a type of pet, is what that arrow means. And so it already has a name, a weight, and a color. And then I'm going to put in here. So in here, I'm just going to have one extra field for dogs, and that's going to be collar. And that's going to be a string. And that's just going to let me tell what color collar they have on. That's maybe not the only method you could, or the only attribute that a dog could have. You could put in something else there. Feel free. Like, this design stage is kind of up to you. And in addition to the say hi method, dogs have another method that cats don't have, which is swim. And swim returns nothing. And say hi returns nothing. And this say hi method should also return nothing. Okay. And then it should be noted that what I'm doing when I say that dogs have a say hi method, but they're already a type of pet, is I'm taking the say hi method that pets have and I'm overwriting it with the dog one. Okay? So let me show you how to implement this a little bit. So I've got my IDE up over here, and on this other side I have my diagram, and I'm just going to kind of follow along with this diagram. So I'm going to define a pet class, and that's going to be, oops, that's not how you make a class, def. And if you're clever, you'll have noticed that I actually have employed something that should maybe have kicked a syntax error earlier. Think about that for just a second here. Pause the video maybe. Pause the video and think about what it is. I did this in two different ways in the videos. And I'm going to splice in here me doing that in the two different videos, and you'll be able to see that in the videos I have this done in two different ways. One is just pause the video and find out what they are. Okay, so oops, the way I do that is by saying class, and normally this should be capitalized, so this is going to be the kombucha class. And the kombucha class, okay, so these are Indian blue. Say hi, guys. Okay, welcome back. I hope you noticed that in one of the videos when I defined a class, I said class something, and then I had parentheses. And in the other video when I defined class, I just did something like this. I did pet, or class pet colon, right? So those two things are going to look like this. So that's the pet class, and then I'm going to make the cat class. And the cat class, I'm going to try to say is a kind of pet. And so I'm going to put that parentheses, and then I'm going to say what it's a kind of, right? So it's a kind of pet. Does that make sense? So it's kind of taking the idea of a pet as a building place to start with. And so what that's going to, the way you would read that sentence is the cat class extends the pet class. And what that means is that cats are a kind of pet, and so they inherit all of the properties that a pet has. So when I put my initialize method in here, oops, I'm going to define an initialize method, takes nothing, and what it needs to do is set a name, a string, a weight, and a name that is a string, a weight that's a float, and a color that's a string. And really, I screwed up. I said it takes nothing, and it should at least take those things, right? So this is going to take a name, a weight, and a color. So I'm going to set this thing to expect itself, right? The self keyword there means that I'm expecting it to get past an object, right? And then it also gets a name, a weight, and a color. And that's going to be, that's going to take self and set the name variable equal to the name. It's going to take self and set the weight property equal to whatever you passed it for weight. And it's going to take the color property and set it equal to whatever was passed for color. Okay, and then I'm going to write my kind of generics. I'm going to write my kind of generic say hi method. And that's going to take nothing. And what that's going to do is just print a formatted string, right? So I'm printing a formatted string, and that formatted string is going to say something like, hi, I'm a generic, gosh, I can't type today, pet, period. My name is self.name, right? The name variable isn't in the scope, so it needs the self.name in order to get the name out of the specific instance it is, right? So it's got to get, it's going to say, my name is self.name. I weigh, oops, that's still not how you spell Joe. Self.weight pounds. Oops. And I'm, and I screwed up, I missed an escape character again. And one thing you can do that's kind of maybe more convenient here, oops, is you can you can actually drop strings onto multiple lines just to make them fit. So, hi, I'm a generic pet. My name is self.name. I weigh self.weight pounds, and I'm self.color. Okay, so let me create a pet just to double check that everything's running, right? Indy, per usual, is my go-to example, is a pet, and Indy needs a name, which should be a string, so that's Indy, and Indy is a fat boy, 68 pounds, he is still a fat boy, and he needs a color, and he is a blue Merrill, is his color. Okay, so now this is not my long-term plan for Indy, right? I intend Indy to be a dog because he's a dog. He's not just a pet. But I just want to check that the pet class is working. So I'm going to do indy.sayHi just to test that. Okay, so now when I run this, I'm pretty sure that this cat thing is going to kick an error, but let's try it anyway. End of line while scanning string literal. Maybe that. Might be that I'm not allowed to break lines like that. Yep, not allowed to break lines like that. Unexpected EOF while parsing, right? So that's telling me that it hit the end of the file before it found out something. And I think the thing it was trying to find out was about the pet, or the cat class. So I'm just going to comment that out right now. Let's see. Oh, and sayHi should take an argument of self. You guys see how many errors I run into when I'm writing code? Like, this is totally usual. It oftentimes takes me 10 or 12 tries to get anything working. Okay. Hi, I'm a generic pet. My name is Indy. I weigh 68 pounds, and I'm a blue Merrill. Cool. All right. So that right there is going to be my fallback, right? So I'm going to comment these 2 lines about Indy out right now because I don't actually intend for Indy to be a pet. I intend for Indy to be a dog. So maybe let me take my cat class stuff that I was working on and instead work on the dog class. Okay, so since I used Indy as my example, he keeps setting up over here. I'm gonna write the dog class first. All right, so my intention is for the dog class to be made roughly the same way the pet class is. But it has this additional property of whether or not this dog has a collar on. So I, being a good pet owner, always put collars on my dogs. So I'm going to set that variable to true for my program because I'm writing this for my personal use. There are a couple different ways to do this. I'm just going to show you what I think is the best way. So I'm going to define that init function for this subclass, right? And that's going to take a self and a name and a weight and a color, right? And the reason it's going to take a name, a weight, and a color is that my intention is basically to just call the pet class, but I'm also going to say that dogs always have collars on. So I'm going to do the collar thing first, just because that's kind of in my head. Oops, collar is spelled that way. Okay, so dogs always get collars. That's self.color is true. And then what do I do with this other stuff? Like, yeah, I could go rewrite the initialize method, but instead what I'm going to do is this other kind of slightly more subtle thing. So what I'm going to do is I'm going to say, all right, dog's a kind of pet, right? So I'm going to say first, go get one step up. So I'm going to go from the dog class to the pet class. So that's what the super function does. It says, okay, this thing is a dog, right? Like I'm in the dog class. So what's the one step up above dog class? That's pet class. So we're going to go get the idea of a pet, and then we're going to call the init method on that. And we're going to pass that what it needs. So that thing needs name, weight, and color. And the reason you can use pet here if you happen to know exactly what it is. It is usually preferable to use super here, because then if you later decide that what you need to do is stick something in between the level of pet and dog, then the super will just keep track of which thing you've put in between there. Whereas if you change it, if you put something else in between there, then you'd have to go find it in the code. So it's just a little bit faster sometimes, right? A little bit more dynamic. It's usually a good idea if you can keep things to kind of relativistic coding instead of hard coding. So this is going to use what the computer thinks the superclass is, not necessarily what you've written in the previous line, which is kind of helpful. So I have this, all right. So I'm calling the way that I make a pet there, right? And then I'm also, oops, and then I'm also setting the color variable to true. You guys see that? Okay, so that's my dog class. That's my initialize method. And then I need I'll define the say hi function. And now this should seem a little funky. So the thing that should be a little funky here is that the say hi function for this class already kind of exists. Let me go ahead and leave that off once and just run this thing. So I'm going to take my 2 lines about Indy and I'm going to put them down here. So this is kind of the cool thing about inheritance. So now I'm going to say make Indy a dog, and then I'm going to get Indy to say hi. Okay, so when I run this, it runs exactly the same way. It says, hi, I'm a generic pet. My name is Indy. I weigh 68 pounds, and I'm a blue merle, right? So what that's doing is that's saying, okay, dog, you're supposed to say hi. Then it goes in the dog class, and it looks for a say hi method. There isn't one specific to the dog class, so it goes up to the next level, which is the pet class, and looks for a say hi function there. If it climbs and doesn't find this thing, it will throw an error. So if I call, I suppose it probably doesn't have a say hi with a lowercase. I'll get this dog object has no attribute say hi. But you know the funny thing is, right? The dog attribute or the dog class actually had no attribute say hi anyways. The pet class has one. And then the thing is that because a dog is a kind of pet, it also has that attribute. So this is why we call it inheritance, because it inherited the method say hi from its parent class or its superclass. Those are this parent class and superclass mean the same thing. Okay, so now if I want dogs to be different in the way they say hi than pets are, I can do that. I can say, all right, I'm going to define a say hi method, and this is going to do what's called overwrite, right? So it's going to look in there first, and if it finds one, it's going to use that one, and it's not going to go any further. So on my say hi one, I'm going to do this kind of differently. I'm going to take roughly the same stuff and paste it in here. And then instead of saying I'm a generic pet, I'm going to say woof, woof. Right. Dog say hi by bark. Oh no, woof woof is down. we're going to say bork, right? So Indy's going to bork at you, and he's going to say, my name is Indy, and blah, blah, blah. So let's run that and see what we get. So we get, now, instead of going to the parent class, right, because it has a say hi method itself, it's going to do that specific say hi method, right? Okay, and then dogs may also have some specific properties or methods. So for instance, we said that it was supposed to have a swim method. And right now I'm just narrating this. It's kind of dumb. It'd be better if it did something, but I'm just going to narrate it. So print first formatted string braces self.name swim. Period, extra thing, okay, is swimming. All right, and then we can call Indy.swim. And then I get my result of saying hi and then also swimming, right? Okay, so that's how we made the dog class. Now say we want to make the pet or the cat class. So I'm going to go back up here. I'm going to have my class cat. I'm going to do this same thing. So I'm just going to snag the code from the dog class. So again, this is making an initialize method that takes a name, a weight, and a color. And then this one needs a little more information because inside and declawed are booleans that this is going to need. So this is going to take an inside boolean and a declawed boolean. I could have done the same thing with the collar, right? So I've got the generic pet class takes name, weight, and color, right? So that's all taken care of. That's going to go set name, weight, and color. I don't have to do that again. But I do need to set these two variables inside the declawed. So I'm going to have my self.inside is the inside boolean that I'm going to pass. And self.declawed is also going to be that declawed boolean that I pass. Okay, and then in my other function, all I need is the say hi method, right? So I'm going to take my say hi method from my dog, roughly, and I'm just going to modify it a little bit. And that needs an argument of self, and that does this. And then I want to, let's see, so Raumau. I don't know what cats say. Okay, so my name is blah, 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 I weigh blah, 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 and I'm this color. And then we should also add some statements about being declawed or not. Oops, you guys see what I did here? I got an extra say hi function definition in there. Okay, so I need another line, and I need to print, and again, a formatted string. And I'm just doing this on a separate line. There's no particular reason for this. You know, you do you, right? So my cat, I want to say, says Okay, so let me maybe make some decisions. So if self.inside, right? So if it's an inside cat, then it should print out I live in the house. And if self.declawed, then we'll also add, so if self.declawed, we'll add my claws were pulled because humans, I'm not sure how political declawing cats is. If you disagree with me, that's fine. I don't really actually, this isn't a strong opinion. It's just, it seems mean. It looks like it would hurt. Okay, so, okay, good. Otherwise, we just won't do anything, right? So we could add some else's there if you wanted. I'm not super worried about it. I'm gonna make a cat. So my cat's name is Rumor. So Rumor's a cat, and then this is where keeping track kind of gets to be a thing. So Rumor's a cat, and okay, and conveniently, right, VS Code is smart enough to figure out which things I'm supposed to be putting in here, right? So I'm supposed to have a parameter that's weight, and so Rumor weighs, shit, what does Rumor weigh? 12 pounds, she's kind of chunky. And she is a tabby. I think she's actually a blue tabby, but all my pets are blue. That's real weird. All my pets are blue. One of them's named Blue. The other one's named Indigo. Should have named the cat after a color of blue. Rumor is an inside cat because I like lizards, and she is not declawed. Okay, and then if we do Rumor dot say hi, Rumor will go ahead and say hi. And then if we do cha-cha, let's see, Blue is my other dog. So Blue is a dog, and Blue's name is Blue, and she weighs 25 pounds, and she is also a blue merle. And I'm realizing I probably should have put in some kind of breed or something, because she's a blue merle Australian cattle dog, and Indy's an Australian shepherd. Whatever. And then I want to do, I'll make Blue say hi while we're at it. Okay, and I'm going to leave the Indy swimming line in there just because. Okay, so looking at the results here of running this, I have Bork Bork, my name is Indy, I weigh 68 pounds, and I'm a blue merle. Indy is swimming. So that's coming from Indy saying hi and swimming. Row Mow, my name is Rumor, and I weigh 12 pounds, and I'm a tabby. Okay, so that's this part. Good. And Blue is a dog, and Blue says, Bork Bork, my name is Blue, I weigh 25 pounds, and I'm a blue merle. Okay, so this video has gotten plenty long. I'm going to add one more thing in here, roughly because I feel like I've done a slight disservice in copy and pasting a bunch of this say hi thing, right? So it seems to me as though the say hi sentence is basically the exact same thing for cats and dogs. The only thing that changed was that kind of greeting, right? So what I'm going to do is refactor this just a little bit. So refactor means kind of a philosophical rewrite, not a functional rewrite. So this right now is working just fine, but I want it to work just fine in a slightly different way. So what I'm going to do is I'm going to say, I'm going to comment out the two say hi methods I kind of have going, right? That one main print line. And then I'm going to think to myself, all right, really what this does is set a greeting, right? So I'm just going to set a greeting string, right? And I'm going to set the greeting to Bork Bork. That's going to be my greeting string. Okay, and then what I'm going to do is I'm going to go up to the super class, right, to the thing that this is made out of, and I'm going to call the say hi function there, and I'm going to pass along that greeting, right? And then I'm going to go up into the pet class here. Sorry, you probably can't see this as much as I would like. Okay, so I'm going to go up into the pet class, and I'm going to say hi. I'm going to look at that say hi function. All right, so that thing just takes a self, right? And I'm going to put the greeting in there as an argument, right? And then instead of this hi, I'm a generic pet crap, I'm just going to put greeting in there. And then it's got a space built into it afterwards, so I just need to be pretty cognizant that my greeting should include punctuation, but not a space. Okay, and so that did this. So that's the dog one taken care of, refactored, and the cat one, I'm just going to take those same 2 lines, and I'm going to set the greeting to round now. Okay, so now when I run this, I get the exact same thing, right? This is totally exactly the same output. But now what I'm doing is philosophically a little different, right? What I'm doing is I'm changing just a greeting variable, and then I'm passing that along to the say hi function for the superclass. And the superclass is expecting a parameter for this, the way it says hi, that's that greeting, and then it's putting it in. So I just want you to get used to the idea at this point that, like, just because something's working doesn't mean it's working in the best way. And sometimes it's worth spending a minute and rewriting something that's already working just to get it working a little better, right? Like aesthetically, it's a little better. So this is kind of the idea of inheritance and just a little basics on UML. Let's see, did I get everything? Name, weight, color, an initialize, and a say hi. You'll notice I didn't put initializes in these. Putting initialize in here was sort of a non-standard choice. You probably don't have to do that. This one, though, I changed, right? So I said that that was going to take a greeting, right, a string. So I should probably make this note that I did that. And then otherwise I have these. This was always set to true, so really I should be putting in something like right, like that's a default value that it has. I'm not expecting it to be a pass. Okay, so there's a whole huge deep dive to do into UML. We're gonna kind of work on it as we go, but for right now, I want to have you think about UML diagrams at least a little bit, because it's good to get started with this. It's generally reasonable practice to just start hacking at something if it's pretty small. But bigger pieces of code need more organization, especially if you intend to split it up amongst several people. All right. Okay, and one last thing here. This is where the difference between is instance and type are different. So let me just throw here, print out rumor. Oops. Let's print out the type of rumor. Right. So rumor is a cat, right? So I'm expecting that print type of rumor, I should get some kind of like class main.cat. Okay, great. Here's the other thought there. So if I use the is instance function on rumor, and then the next thing that it's supposed to take is a type. So if I put pet in there and hit run, I get this true back. And so type, right, is one specific thing. It is, you feed it an object and it tells you what that thing's most specific type is. It does not tell you which superclasses are associated to that thing. So rumor is a cat, but a cat is a pet. And so when I ask for the type of rumor, right, I'm going to get cat because that's the most specific thing that rumor is a type of. If I use isInstance, I can check whether it's also an instance of something else. So I can say, is this thing an instance of pet? Sure it is. And it should be noted that everything in Python is an instance of object. So if I hit run on this, I will see that rumor is an object. And the reason that rumor is an object is because Python has an automatic class called object, and everything is an instance of it. So if I even feed a number in here, probably get true out of this, right? Because 10 is an int, which is a kind of object. So got to be just a teens careful with that. We tend to use the word object when we mean a like user-defined, like encapsulating thing, but Python is a bit smarter than that. It treats everything as an object at the bottom. And so when this question, is instance object, is basically useless. IsInstance is a useful thing for finding out whether kind of how your superclass diagram works, especially if you're working with something that you don't really quite understand, which happens to me when I pull stuff out of a library that I'm not used to. If the documentation is not great, sometimes I find myself playing isInstance games to figure out what things are. So take this for what it's worth.